So this is number 3 here. During a demonstration, an instructor placed a 1 kilogram mass on a horizontal table that was nearly frictionless. The instructor then applied various horizontal forces to the mass and measured the rate at which the mass gained speed, or was accelerated for each force applied. The results of the experiment are shown on the table. Plot the values given in the table and draw the curve or line that best fits all points. Describe in words the relationship, find the slope and y-intercept, and so on. So let's do the plotting first. I'm hoping that you guys had a chance to do this. So we're going to go like 0, 5, 10, 15, 20, 25, 30, and this is going to go up by, looks like the same thing. Oh no, 0 there. 0, 5, 10, 15, 20, 25, and 30. And we got 5 and 4.9 is right there. 10 and 9.8. It seems to be going up by the same amount each time, doesn't it? 15.2, oh, slightly above. 20 and 20.1 is right there. Are these almost perfect data? Almost perfect, right? Yours is not going to be quite as perfect. I can probably do this with my straight line. Right? It's like there, it is perfect. Right? Okay. So we did that. Describe in words the relationship. In other words, what kind is it? Is it linear, quadratic, or inverse? Linear, how do we know? It's a straight line. Right? It's a linear relationship. As one goes up, the other goes up the same amount. Find the slope and estimate the y-intercept. Well, I know what the slope's going to be. I'll just pick any two random points. That one there is going to be, the y value here is 29.9. The y value here is 15.2. The x value here is 30. The x value here is 15. And you should get a slope that's pretty close to 1, right? Yeah. This happens to be 29.9. Let me actually do the math, I guess. I get 0.98. But if you had somewhere in that range, you'd be fine. I'm looking for work. I don't need the exact same answer as you, right? Because it's a bit of an estimate. And you're going to estimate the y-intercept. Well, what if the force is 0? What's the acceleration going to be? If you don't push, 0, right? So the y-intercept we're gonna say is 0. And to write the equation relating to the force, so it's going to be y equals mx plus b, or y equals the slope, 0.98x plus b, which is plus 0. And I guess really you should use, instead of y and x, on the y here we've got the acceleration, and the x is the force, right? So really, instead of y, we should have a equals 0.98, and the x is f. Do I need to have plus 0? No. What's the formula that has f and a in it that also includes masses? You learned it in grade 10. Newton's law. So I was just waiting to say it. Tough. Thea, what's Newton's law with f and a in it? F equals? Well, I just want the formula. Don't know? Grade 10? Come on, somebody. Mallory? Force equals mass times acceleration, is it not? Mass times acceleration? So here, we would actually, could I rearrange this? Could I rearrange this so that it matches that? Like if I put F there, how do I get F all by itself? I'd have to divide by 0.98, right? Divide by 0.98 is equal to F. Well, that's not m times a, right? What I'm trying to say to you is, what's the mass? Do you know? Is it 0.98? It's actually, this is going to be 1 over 0.98 times a is equal to F, and so the mass is actually equal to 1 over 0.98, which I think is like 1.02. You can find out the mass of the object. Okay? Now normally, to make it sort of work the slope out here, the independent variable here is the force, because that's how you're pushing a certain amount. right? But, so what I'm trying to say here is that the slope in this case, what's the meaning of the slope here? Like, what value does it represent? We've had meaning of slope, we've had like density, we've had like reaction time, we have pi. What's the meaning of the slope here? It's a little tricky. I know, that's why you're all staring at me like, I don't know. Remember, the other trick was we could look at the units, right? What's the units for acceleration? Meters per second squared. And the units for force are? Newtons. Okay, so our unit for our slope is going to be meters per second squared per Newton. That's a really weird unit. You've never seen that before, right? Yeah. It's a really weird unit. Does anyone know what the definition of a Newton is? I'm not expecting anyone to know. I know, because that's what they pay me to do. The definition of a Newton is, meters per second squared, is kilogram meters per second squared. That's a Newton. 1 Newton is 1 kilogram times meter per second squared. Find a slot to count. And you'll notice that the meters per second squared will cancel, and you're left with actually 1 over kilograms, which is the inverse of the mass. That last part there, don't worry about that. That's kind of confusing, right? You're probably going, I don't know what he thought. That's okay. I will make sure that any kind of assessment where I'm asking you what's the meaning of the slope, that it won't be that complicated. But there's always a meaning to the slope. There's always a meaning to the slope. Were you stuck on a bus, Anna?
Yeah.
Yeah? Maybe they couldn't get the back door open or something like that?
I got a secure.
Oh, that's good. Alright. Are you, I'm not going to say real comfortable, are you kind of comfortable with this sort of stuff? What do I expect you to be able to do? I expect you to be able to make a graph. I expect you to be able to find the slope. I expect you to be able to estimate the y-intercept. I expect you to be able to write an equation. And I expect you to be able to come up with the unit and the meaning for slope. And I promise you that it won't be a difficult meaning of the slope. I'm not going to throw something weird into it. But I would expect you to be able to recognize density, or a time, a reaction time, or some quantity that it'll be something that you should be familiar with. Okay? At the very least, you should be able to tell me the units for the slope. Okay? Does that seem fair? See the equation now, so that's good. Okay. So, seeing as it's 2017, we're going to be doing a lab, and all the lab courses are going to be like this. So number one today is make sure that everyone's got a password. There's a lot of you in here. I think there's more than 25. So some of you are going to have to share a laptop. And I need to know that you can graph on a laptop as well. Again, 2017. So I'm going to say, at the very least, you need to have 1 laptop per table, but there's been some tables with people can have 1 each. So you guys work that out. I'm going to do attendance. And then we'll go from there. Take this data from the last one here, this 5, 10, 15, 20, 25, and 30, and you're going to punch that in here. So 5, 10, 15, 20. Does it go to 30? And then the other data, the 4.9. Come on. Okay, so you're going to plug that data in like that. And let me just zoom in a bit here. Right? Because we're going to be making a graph out of this data.